see talk?
Yeah, it's working.
Yes. Okay. So I think it works. Yes. So it works.
Good, good. Okay, I will also, for the same reason, I will also make you host at some point, just to avoid that everything shuts down if my Wi-Fi breaks. So sorry about that, but it's
Oh, it's
good.
not a problem. It's okay.
Now you don't have to do anything. Like,
yes, okay.
I will wait. I will wait until people come in, so that you don't have to accept them. And then I'll let them.
I have to select who is presenting.
No, they people can share without consent.
Okay, okay.
Okay, let's wait 2 minutes and then we start. Yeah, I think we can go. Maybe Aurélien, for the first 5 minutes, if you could keep an eye on the people that might get in.
Yes, if I see a new participant.
Yeah, exactly. So.
Yes. I received no new one.
Yeah, so I know that Mauro Dariano will be joining us at 4.
Okay.
And there might be other people joining now. But so now you're a host officially. So. Okay. Okay, thank you. So yeah, I guess we can start. So thank you, everyone. It's nice to see you. Few, but very good. So we, as planned, we're going to have a discussion on the previous 2 talks on ManyWord from Paul and Lev. So the discussion is supposed to be free, but I guess there's going to be short presentations from people that have issues that want to clarify, and from the 2 authors. So yeah, I think we can maybe start from Paul, and then I'm going to hear from Lev. I know Aurélien wants to say something too.
Yes, I have a few things. Yeah.
Cool. And then we're going to leave time for other people. Of course, we can have follow-ups in the meantime. Okay. So also one thing, this is the last meeting for this year. But yeah, very happy about how things went in the last month. So I would be very happy if you can still join us next year. I will send you a calendar. I already have a few people in mind to invite. Some of you are already there. So yes, that's it. Paul, you can go whenever you want.
Right. Well, thanks, Christian. Been thinking quite a lot about this since the talk, and had some very useful interaction, a lot of interaction with Aurélien, for which thanks very much. It's been very useful. This is where we got to the last time, and this basic picture. The guy at the top, the electron in his environment is a set of elemental electrons, each in its own parallel universe. So there, in his environment, there's this indefinite object, and the indefinite object is being interpreted as a set of definite objects, a set of electrons, a vast set of electrons spread out all over the place, wherever there's any amplitude for that electron. And each of those elemental electrons is in where his mind spans that multitude of universes where elemental electrons have linear trajectories. So all the guys down at the bottom, they're not subjects. They're, if you like, look, they're loads of doppelgangers. There's only one subject. His mind spans all the doppelgangers. If you remember, the analogy was between a book and a novel, and having one novel but a lot of copies of a book. So Chip Sebens posed the question, okay, well, what about the dynamics of all these elementary electrons with their linear histories, their linear trajectories? And I rather sort of lamely replied, oh, well, isn't it implicit in the wave function? And I hadn't really started thinking about it, because it was only really in preparing for this talk that this idea was crystallized out as it is here. And so when Chip posed that question, I did, a paper of his did sort of vaguely pop into mind where he talked about some sort of Newtonian physics. And it was in this paper at the top left, which was published in 2015. And I had read, and you know how, well, I can have huge lacunae of memory. I just had very vague recollection of it, but I went back and read it. And really, it's, how can I say, the picture he's paints there is similar to the one I've just given, except that I'm seeing it from the point of view of the unitary mind spanning all of the universes, whereas he's looking at it more from the being inside one of them, if you like. But here's the abstract for that paper. Here I explore a novel, no-collapse interpretation of quantum mechanics that combines aspects of two familiar and well-developed alternatives, Bohmian mechanics and the many worlds interpretation. And so the idea being that the dynamics of in those individual elemental, the dynamics of the elemental electrons down at the bottom there, and then in the multiple parallel universe could be given something like by pilot wave theory. And in that paper, Chip proposes that you can actually rewrite the pilot wave theory in terms of a sort of classical Newtonian mechanics. And then in contact with Aurélien, he put me onto other stuff as well, but that idea has been around in various forms. There's a paper of about 2011 of by Tipler. Anyway, there's some interesting stuff there. And then we have this in a quote from John Bell in his book: the existence of such a preferred set of variables is one of the elements in the close correspondence between Everett's theory and de Broglie's. Well, again, making a link between the many worlds and pilot wave. And of course, yeah, they're both very much dealing with sort of trying to get an emergent classical world. They're seeing it in different ways. The issue being, how do you have classical phonetic in the world, given the quantum mechanics? We'll come back to that maybe in the discussion. And then also in Geoffrey Barrett's book, and in a paper, an interesting 2005 paper in British Journal of Philosophy of Science, Jeff Barrett gives a sort of overview of this sort of combination between many worlds and having these multiple divergent partitioning parallel universes. He calls it, so he says, a many thread theory is ultimately just a hidden variable theory, while one simultaneously considers all physically possible worlds. So you see, the idea of this having an ensemble of, for example, pilot wave worlds, in each of which has a different initial condition. So they're all, you are considering the whole multitude of them rather than one single one. So that sort of idea of linking many worlds with what Jeff Barrett would call the idea of multiple threads, it has been around for a while. So I'm just really giving a different take on it, but the different take on it involves this different mind-body relationship, which gives you the different sort of features which I've been talking about. So what's gained by the perspective of, instead of being situated within the individual universes, you've got this dichotomy between environmental objects, which can be indefinite in the environment of a subject, and elemental objects, which are not in an environment at all. Everything which in our environment is, according to the idea, a set of elemental objects. What's gained by this perspective? Well, one thing is that it provides uncontroversially local beables for many worlds. I mean that in the sense that the argument which Lev gives, the sort of central, centre of mass argument, which has been around in various versions for a while. It's in a version of it's in chapter 3 of Wallace's book, and so on. What can say is that it's not uncontroversial. I mean, many worlders support it, but it's not accepted by pilot wave people, because it doesn't supply local variables that they think are local beables. Well, the argument could go on and on, but anyway, what I'm proposing here is local beables precisely in the sense of pilot wave. But along with it, we've got a metaphysics for giving us indefinite objects as well, and non-locality in the form of pure states, and I'll come to the distinction between pure and sort of mixed states in a minute. But so you've got beables of both forms, and you've got definite and indefinite. However, there could be an irony in that, because it could say, well, okay, many worlds has finally got to local beables, but why then have many worlds? Why not just have one and be done with it? So, which is what Aurelian perhaps favours a bit, but no, we're both talking about it with open minds. Another advantage, well, Du Bois-Bohm theory is vindicated as an entree into the domain of elemental quantum mechanics. What do I mean by that? Well, it's the idea that the intuition that quantum mechanics as is incomplete, and that more physics is required, is sort of vindicated. Du Bois-Bohm theory being a way of pushing physics into another sort of area. Of course, the Everettian camp has tended to say, no, the whole advantage of many worlds is that we don't need any new physics. So there again, there's a conflict, because the point, so again, is there an advantage in having them both, being able to combine both, to be able to have the perspective of many worlds and to be able to investigate what could be an extremely interesting, and who knows where it might lead, development of physics into thinking about how the dynamics of the elemental particles work. Is it Newtonian? Is it pilot wave, or is there something else? So I mean, as Chip said in his 2015 paper, in a way, this is opening up a new avenue of physics for exploration. Another advantage, well, it looks like EPR entanglement locality is preserved, but I put in a question mark because there isn't overall agreement on this. I know Aurelian doesn't agree. I mean, I've always thought in terms, if you've got subjects who split, then the EPR type setup is not going to work. So it looks like that the non-locality is there, because if you reject Everettian splitting, but if you have Everettian splitting, it disappears. But then I think this is not, there's no consensus on that. But I would say again that there needs this distinction to be made between entangled locality and pure state non-locality. The pure state non-locality is just the idea of the electron being spread out in space as a set of electrons. But with entanglement, you've got something else going on. And I would just point out that if you've got two particles entangled from the point of view of the set theory, then each one has got elements wherever it's got amplitude. So where they've both got amplitude, they've both got elements. So there's a sort of sense in which you could sort of say that the particles are locally in contact with each other in the sense that they've both got elements in the same places, but then something to discuss perhaps. And then also that finally, if you've got a Born rule for many worlds, and I think you have to postulate the Born rule for many worlds, and in my last paper, the postulate I suggested is what they call the no collapse probability postulate, which just identifies branch weight with objective probability, but that's how I would do it. But once you've got that, then you don't have any idea of a selection of initial conditions for the Vaidman theory, because within the constraint of the Born rule, all the possible initial conditions are covered. So what's lost by adopting this perspective? Again, a perspective which makes an absolute distinction between the environment and some sort of underlying mind-independent reality, which we never observe, which is always elements of sets of which are the objects in our environment. Well, there are four very cherished and largely unquestioned assumptions which we're going to have to drop to adopt this perspective. The assumption that multiple isomorphic doppelganger instance multiple subjects. There's a very strong intuition in favor of that, because if I tell you that there's a copy of your body on another planet which is exactly like working over the spec, then the normal idea is that, well, that's some other person way off, millions of light years away, if not very much further than millions of light years, and their life is nothing to do. Stick a pin in them, and that's nothing to do with me. But from this point of view, no, if such a duplicate of your body exists, it's not far away at all. Actually, what you call planet Earth is a set of two planets, which are in sort of picturesque and superposed one on top of the other. Another assumption, we have to drop the assumption that a set of two apples cannot itself be an apple. Well, you know, for a lot of people that looks like a category mistake, sets of abstract objects, you know, how can you call it a concrete object? So that's pretty resistant to our intuition. We have to drop the assumption that probability requires alternatives. I know that Lev, amongst others, would insist that it does, but as I've been trying to explain, that if you allow the identification of branch weight with objective probability, then it doesn't, all the branches exist. You don't need alternatives for probability, but you have, and that was the point of the thought experiment I did at the outset with the single mind spanning the stochastic universe. Probability is intelligible without alternatives. And finally, well, the assumption that we each have a single future, and and Lev wants to drop that assumption as much as I do. I mean, it's very strange. On the face of it, we've been so used to thinking of having a single future, and yet, when it comes down to it, does it really change? That's the point. I mean, it's all very sort of, seems very radical and sort of metaphysics, but I would say in the end, probability is probability, whether it's stochastic or dendritic, whether it's between alternatives or between coexistent futures. But You know, that's what I would argue. So that sums up my thoughts up until now about what I've said so far.
Thank you, Paul.
Yeah.
I don't know if we want to just comment directly on that, or keep having like general long comments by the authors, and then I don't know how you feel. We are not too many people, so we can just vote or decide now.
Answer no, like that to keep the idea fresh.
So I think, okay, Tony has a finger, so if you want to ask something now.
Actually, I have several fingers.
Yeah.
There are a number of things I wanted to ask, but one thing which has just come into my mind as a result of that last slide of Paul's is the assumption that we each have a single future. Now, I'm with Paul in not believing that, but it's not as if it was a new idea. And that idea surely goes back to Aristotle, who said that future tense statements don't have a truth value. There is no single true statement about what will happen in the future. So that seems to me to be actually a very interesting and quite traditional idea. Shall I leave my other points till other people have had a go?
If you want to, I don't know, anarchy. Paul, if you want to reply to that, then Tony can ask the other points.
Okay, so yeah, I didn't say, it's Tony who came up with that. Yeah, as I would expect. Yeah, look, I can understand that could be a way of looking at it, but the difference is that I'm saying that all those, it's perfectly true for each of those futures that they will occur. I mean, it's not a matter of indefinite truth value. It's true that they will all occur. So it is different in that respect.
Yeah. Okay, it's different from mine.
Yeah.
So just to say again that there is a, if I understood Tony correctly, he says that we cannot say anything really certain about future. And I think we can.
Or we can, but we can't say, we can't be sure that what we say is definitely true. Which is where my understanding of probability is, or I know that's an individual understanding. The probability is how true it is that something will happen in the future.
Okay. I believe in probability when you have several alternatives which all kind of plausible, and you want to define to decide which one will happen. And now what I still hope the plausible situation is that we roughly know nature. So we do know what will happen. So, but I still don't know, as it will not be single of me, because I will split to many of me. But I definitely know that this is what will happen. I cannot connect myself to a particular me in the future, but I have no any uncertainty about the future. I know when I perform quantum experiment, I know exactly what will happen. That there will be multiple of me will appear.
But do you think nature connects you with any one of those people in the future?
All of them. I'm related to all of them.
But no particular one?
No particular one.
And you will never be aware of being all of these people. You will only be aware of being one of them.
Yes, but if I will have super technology, I can test if my assumption is correct, because I will perform experiment in which I will erase the memory of me. I will not remember that I've been in several situations. But the result of experiment can be explained in a coherent way only on the assumption that all of me existed in parallel.
Yes.
But Lev, can you tell me if your explanation about this hypothetical test of quantum mechanics will not be also true using Bohmian mechanics? I mean, you cannot distinguish, probably if you are able to make a quantum mechanical test at the macroscopical scale, I think you will not be able to discriminate between the different theory. No?
I can discriminate between collapse theory and non-collapse theory.
Okay.
Now, about Bohm, it's kind of, I would say, 99.9% that there is no experiment which can discriminate experiment between Bohm and many worlds, and we have to kind of look on aesthetic of one theory and another theory. Although there is this kind of 0.1% of this surrealistic trajectory. So, because in most cases, a Bohmian world, kind of this conditional wave function, is one of the Everett worlds. But if we have kind of situation with surrealistic trajectories, this is not so. Still, I need surrealistic trajectories for kind of object complex enough to be conscious. Because if I'm outside and perform surrealistic trajectory experiment, it's still cannot distinguish between many worlds and Bohm. But if I'm kind of inside, I myself in this surrealistic trajectory, and then I can kind of experience if I'm in the Bohmian world or I'm in a many world world. But, and again, it's not clear. I think this is complete science fiction, but it still doesn't let me to say that the 100% identity between many worlds and Bohm from experimental point of view. It's 99.9% identity.
Okay, so the rest over is like this Wigner experiment.
No, not Wigner experiment.
Not Wigner?
No, not Wigner experiment. The experiment of Berger and Glare, who suggested the experiment, then when you calculate Bohmian trajectory, it takes right arm. But you have a kind of a bubble chamber with special bubbles, which they develop not immediately, but it takes time until they develop. And your bubbles are all on the left arm. So you kind of, if you're experimentalist later, you think that your particle left on the left side. But if you are kind of serious Bohmian and to make your calculation, you say, no, my bubbles fooled me. It was a bad experiment. Although bubbles all show left trajectory, the real trajectory is the right trajectory. This is what I call surrealistic trajectory.
Experimentally, I think it will always be giving the same because it's the same theory. So I don't believe that it will change. But because even this trajectory are very funny or strange or exotic, if you admit the Bohm rules as a postulate in Bohmian mechanics, it will never. All this you will never be able to have the test for this. You will never
again.
Even if you make yourself a part of the system and you say you are a kind of particle in an interferometer like this one, you will not be able to realize it because if you were able to realize it, it means that you are able to have information on the environment and then you break the coherence of the wave packet and then it doesn't work. So I think that is not possible to. It's the reason why I'm speaking about this Wigner story because recently there are a lot of debate about Wigner experiment and I had a lot of discussion with that with many people and I think they're confusing about that. They don't realize that the ontology is for everything, including yourself. So if you are if you are a part of the interferometer of the particle, you will have to obey the rule of quantum mechanics. So I don't think that it will work. But okay, this is as you say, it's very science fiction or exotics. Maybe we have to. This will be very interesting to discuss more in detail. These things.
I just want to stress it's not the Wigner type experiment. It's another experiment. Because if this particle in this surrealistic experiment has consciousness, then according and by fiat, we feel only Bohmian position. So the particle will feel right, moving on the right arm and getting kicked from the mirror on the right side. And but if I believe in many worlds, then the world which will really exist for this particle is on the left side. But it's really complicated to think how it can be, how I can devise an experiment with conscious being in this surrealistic situation. I was not able to do it, and maybe it's impossible. I understand this is your intuition.
Yes.
So I wonder if there were other questions from Tony.
Yes, well, about Paul's basic idea of having a set of elemental electrons, I'm puzzled about how the relation between that set and the quantum mechanical wave function, because there is only one, or if I understand it right, a set is just one thing that you have all these electrons, but there can be many different wave functions with all those different electrons in, because they give different weights to different ones of the elemental electrons. So how does your idea incorporate those different weights for the different elemental electrons so as to get to a wave function? How does it connect with the wave function?
Well, if you, what you're talking about is the weights of the elemental electrons. I mean, yeah. The idea would be if there's got some region of space and there's a certain amplitude for the presence of the electron there, then the squared amplitude will gives you the measure of the elemental electrons which are situated in that region. Well, just to go on, so I think the point is, I mean, that's really the point which sort of follows on from what Chip said. I mean, the evolution of the wave function has to be in whatever the dynamics is of the elemental electrons. So if in each universe it's pilot wave which is operating, then the wave function is being manifested via the guiding the wave, the pilot wave, which is sort of, so it seems to me that the configuration of the elemental electrons in three-dimensional space will be changing over time in accord with the assignment of amplitude to as time goes on by the wave function, no?
So right, so as well as the set, you have the wave function as an additional element.
Absolutely. I mean, and that's what was, I was sort of coming to at the end of my talk, and you know, as I said, these ideas have been sort of really developing in recent weeks, and I haven't seen that what's missing is of course, you do need to have that extra physics, and that's what, as I said, vindicates the sort of project which pilot wave theory is, which is extending physics into another domain of, well, the domain of what are called hidden variables. I mean, I hadn't thought of what I was praising as hidden variable theory in the sense that the hidden variables, they're sort of which are the elemental particles, they're not in the environment. They're in everything in the environment. Every object in the environment is composed of sets of them. So we never, in a sort of picturesque way, we never come into sort of direct contact with them, if you
right.
like.
So it really is very like pilot wave theory, except that instead of having a single variable, you have the whole set of elemental electrons.
That's right, and it's what Jeff Barrett called a many threads theory. And you can have different sorts of threads. You can have Bohmian threads, or you can have perhaps these, Newtonian interacting worlds, which is what Chip Sebbins was proposing, and what Tipler proposes as well, and perhaps, as yet undiscovered sort of ways of developing those ideas. But I mean, and the point being that that's very much the question, is, having gone that far, is there any advantage to having a whole load of these worlds instead of just one? Why not just do just one? Well, I think that having the whole set of them is what helps you to deal with the problems that you have with something like pilot wave, particularly relativistic problems. That they could be mutually beneficial, a sort of symbiotic process between many worlds theory and pilot wave theory, if you like.
But I'm what's coming into my mind is the echo of Wallace and people saying that this is just Everettian theory in a state of denial.
Well,
in other words, you don't need. You wonder. The need for the elemental electrons is a matter of mental comfort rather than anything more.
Wait, well, I mean, they would say that because they think that they've got local beables, but that's what I would dispute. I mean, David Wallace thinks he's got local beables with these emergent patterns in the wave function, and I don't think that's the sort of thing which a beable needs to be. I mean, this is what we were getting back to last week. It needs to be something more like what a beable in pilot wave theory is, because the thing is, what the many worlds, what David Wallace's many worlds has indefinite states in the environment. But they're microscopic and they're being ignored but it's just not as I see it, it's just not good enough to have this sort of center of mass sort of argument for you've got a sort of reconstruction of a classical object. What is it actually made of? As I said last time, what's the actual stuff of it? Well, the actual stuff of it is the particles down below, which are in indefinite states. And if you don't have a metaphysics for indefinite, if you can't give an explanation of what these indefinite states are, then there's a gap, and that's what I'm trying to fill. I mean, many world David Wallace style many worlds theory will explain a superposition. I mean, it will explain Schrödinger's cat they'll say, well, yeah, it's a superposition of a dead cat and a live cat, and they're each in different branches. Okay, fine. But the thing is that there are still, even before branching, there are still microscopic superpositions in the environment, and that's the gap. That's why the way I interpret it, that's why people like Tim Maudlin just think that the centre of mass argument doesn't do it. You know, it doesn't hit what the question which needs to be answered.
But I just thought a beable means one definite thing, which bees. But you have this whole collective elemental electrons, and no one of them is the one, which is the beable. So I don't quite see how your theory has beables.
Well, the thing is, I mean, in a way, the electron, the electron in the environment in an indefinite state is the electron cloud, if you like, is a cloud of pilot wave-like beables. Each one is a beable. It's got a definite position, definite momentum, and there can be, loads of them in the same place. That was just the idea of that's the idea that this sort of multiplicity adds a sort of non-spatio-temporal extension to the world. This sort of what I call the cardinality of the environment. I mean, so I would say it's not one or other of the elements. They're all that myriad elemental electrons which are the elements of the set, which is the electron in the environment, are local beables, I would say. Yeah.
Well, I think perhaps there are different ideas of what counts as a beable. Unfortunately, we can't ask John Bell what he would think of this.
Yeah, well, there are lots of unfortunate absences in our branch of multiverse.
If I may do some self-advertisement, I've been working on whether the idea of local beable as to have as a desiderata this idea of determinacy. I'm working on a paper on this now, so I'm very interested by this exchange, because I believe that in a way Bell seemed to sort of assume that the idea of local beable has to come with this idea, classical idea of being determinate, being definite in one place or another. But on the other hand, they seem to sort of, at a later stage, they seem to also like spontaneous collapse models, where it's not really clear whether you can achieve completely this determinacy. So I'm honestly like still not sure neither whether Bell himself would have thought determinacy ad desideratum, nor whether people that followed him today think so. I had some exchange with like people that have accounts like primitive ontology, people like that, which are sort of inspired by Bell. And I'm not really sure whether this determinacy is a desideratum. But I also have a small finger on the exchange, which is, I mean, I agree with Paul's intention. Paul knows. I like very much this idea of try and look for this sort of mid-level of reality, while you have the wave function at the fundamental level, say, and you have the microscopic objects that are determinate, like tables and chairs, but you still have to account for this middle level of electrons that seems to behave like clouds. Also, Bell has a nice quote about letting electrons enjoy the cloudiness of waves while allowing chairs and tables to be definitely in one place. This is in the proceeding of the Nobel Symposium. So I like this idea of looking at this middle level. As you know, Paul, I shared this, but I also shared what Tony was saying about, you know, it's not really clear whether this set elemental electrons, elemental objects story really achieved this, but not because of the indeterminacy, but rather because I noticed that many people sort of protested or were puzzled about this account, in the sense that they were sort of, I think John said something like this. It said, it's not even clear whether I can teach set theory and say something on the lines you seem to suggest. And it's really like, even intuitively weird to believe that objects are made of sets, because it seems, as you said, it seems a category mistake. So my very quick question is, don't you think that there are other ways to achieve a similar result without necessarily committing to oneself to this idea of objects being composed of sets? And I say this because we both know that there seem to be some accounts in philosophy, like Jessica Wilson, Calosi, the one I also like. So I wonder, don't you think that you can sort of disentangle the issue the motivation you have to pursue this account and the specific account you have chosen? It seems to me that you can. And if you go for the Jessica Wilson type account, which I'm going to say to, I think many of you already know because I've been talking about this for months, but like before I say something more, let me say the reason why you should prefer this is because it seems that you can very easily communicate what the account is. And then of course people can disagree, okay? Can disagree, can say, well, I don't like it, but at least I can easily communicate it to other people, right? Well, it seems that in the idea of the elemental set, I'm not saying that you don't have hope. I'm sure you can explain this account, but it seems very difficult even to come up with a convincing story of what the account says. Well, in the case of Wilson, the story is simple. An indeterminate object, or an indeterminate state of affair is a state of affair where an object instantiates a determinable property, but no unique determinate. For instance, an object that is colored, but that it doesn't have a unique color. So this might seem very weird from a metaphysical perspective, but at least I mean, my grandmother would understand. Then she would say this is crazy, but at least she would understand. And this is the possibility to communicate that the account is important in the context of metaphysical indeterminacy, because philosophers have been skeptical for a very long time about the very idea of ontologic indeterminacy. So if we have an account that is easy to communicate, at least the skepticism is, addressed. There is a thing, but I'm asking and sharing, so this is weird for me.
Okay, well, shall I just respond to that now?
Yeah, sure. And then
okay, look, fair enough. I mean, how it's easiness to extent. Look, I'm absolutely open to the alternative ways of doing this. How alternative accounts of indefiniteness. I think, you know, it's something which has been really neglected for a long time. I mean, it's sort of well, either you do without it altogether with pilot wave, you get rid of indefiniteness altogether, or, and I think that's what many worlds has done, you sweep it under the carpet and it sort of, it's down at the microscopic level. So, you know, it's okay if it's a bit weird down there, don't need to look at that. As for sort of ease of explanation, well, I mean, I totally agree that you've got this sort of category mistake idea. There was some sort of intuitive, you have to resist some powerful intuition. But I would say that, look, if you told your grandmother, well, think about an object which is coloured but hasn't got a definite colour, what's she going to imagine? Well, I don't know. I don't know if she's going to get, okay, if you'll say so, but it was a bit transparent or something. I don't. But then what I'm saying is, well, like here we are. I've got two apples. I've got a red one and a green one. The set of those two apples is an apple with indefinite colour. And then when you say, yeah, but come on, you know, how do you see that? Then I have to give the account in terms of the two people on the two planets, and you put the red apple and the green apple in identical boxes. You send them up to the two planets. The one subject on the two planets has a single box in front of him, and inside that box is an apple with indefinite colour. But when you open that box, you're not going to see an apple with indefinite colour. What you're going to do is split into one person who sees a red apple and one person who sees a green apple. So in terms of ease of communication, I would say in both cases, it's hard to imagine how the proposed object, it's hard to imagine it. I mean, you say, okay, there's this object which is coloured but hasn't got a definite colour. How do you imagine that? I say it's the set of the two things. How do you imagine it? Well, I can't imagine it, but I can give an account of what the relationship of a subject would be to that object. I mean, I've got this account. I mean, the thing is, you can't, in a sense, you can't have a naked indefinite object.
It happened to me yesterday.
As soon as you try and observe it, you split. You see a definite object. That's. But anyway, yeah, they're different accounts. But on the level of intelligibility, I think they might have equal difficulties somehow.
I think I agree that you have to pay some price because it's a counterintuitive idea. I think that, you know, from a philosophical perspective, usually what people do is to say, if you grant me that this weird metaphysical principle might be plausible in some cases, then I can explain you a lot of stuff. This is, you know, sort of holistic picture that, you know, methodologically can be you know, a lot of people likes it, let's say, but still, so even if we compare at the level of, you know, what price is worth paying, right? We both want to pay a price in order to explain something. And this is the game I'm playing, right? So I'm playing this game, right, and we are asking ourselves, what price is more worth paying? And you're saying, well, the price I want you to pay to achieve the same result, right? We want to achieve the same result. Explain this indefiniteness, ontological indefiniteness. The price you want me to pay is that I have to accept that objects can be made of sets. Now, sets are abstract entities. So either I change the idea that sets are abstract entities, or I have to accept that objects can be made of abstract entities. In my case, the only metaphysical principle I want you to drop, so the price I want you to pay, is there is this very plausible principle about how properties and determinable and determinate properties are related, namely that determinable properties are simply disjunctions of determinates, And I'm saying, this principle, you should drop it. This is the one thing you have to pay. You have to drop the idea that determinable properties are nothing over and above these junctions of their determinate. They are not that. They are something else. If you drop this principle, I achieve the result. And you see, I agree that it's, again, it's a sort of, let's wage the price, the prices we're paying. I'm just saying, it looks like the determinable sort of account as a way less costly price to pay. That was my idea.
Okay, I mean, I'm happy to let somebody else speak rather than sort of respond to that.
But it was sort of more a suggestion because...
Right, okay. Well, look, let me just say very briefly. I mean, to be negative about your proposal, I would say, well, in a way, you've just sort of told me what this indefinite object is by just giving me a definition of an indefinite object. You know, an indefinite object is, for instance, something which has got color but no specific color. Okay, but then how can something be like that? I think my answer to that. But on the other side, this issue of the gulf between abstract sets and concrete objects. I mean, something that I have said in my papers and that I haven't mentioned in the talk is that a very famous set theorist, Willard von Orman Quine, actually made a proposal for how you could think in terms of concrete objects as sets. It's in his book on it's called Set Theory and Its Logic, and he says something like, look, I can take a concrete object to be a set which is its own sole element, and the unit element of that set is, and I can identify that too, and the unit element of that, I identify them all as being one and the same thing, that concrete object. And what he says is, look, that it's just a sort of, in a way, it's sort of metaphysically neat because it sort of brings in everyday physical objects within the scope of set theory. And he says, well, it does no harm to set theory. And it's true, it does no harm to set theory, because to define individual objects as sets in that way has no impact on the use of set theory in mathematics, which is where all its utility lies. The set theory is for building mathematical objects. And so what I'm saying is, look, you know, that's all taken the first step. We're at liberty to take a second step and say that, okay, but let a set of these Quinean, I mean, in the literature, these individuals defined in that way are called Quine atoms quite often. But Quine atoms are often sort of spoken of as if they're sets which have themselves as their own sole elements. But I mean, there's this Quinean individual, which is defined in set theoretic terms. Okay, that in a way that's the first sort of baby step of taking set theory into the field of physics, if you like. But if I can go further, and if I can just say, well, look, I can just say that a set of two Quinean individuals is itself an individual, and that it has the properties which its elements share. And again, it sounds crazy, but what it's doing is, remember there was this phrase when Cantor invented set theory, and was it Hilbert who said he sort of created a paradise for mathematicians? Well, what I'm suggesting is that actually, without doing any harm to the relevance of set theory to mathematics, we can extend it into physics and create a sort of paradise physics, because you can construct indefinite objects out of sets. But
this is a nice way to start the paper. Well, I have some quick follow-up, but I think there are many other things to discuss. Very quickly, I'm not saying that there are no good prospects to develop this view, and actually, you know that I would be happy to, you know, to see the stages of development. What I'm saying is that given that you have these two distinct sort of projects, both that seem to be you know, original, and people are not really keen to accept them because they are revisionary. The fact that you put them together might do harm to both of them in a way. So right. I was whether disentangling the two issues clearly can help you, because you can say, okay, there is one issue, and that is, let's accept this indefiniteness, and then we have to account for it, which is another issue. And you can provide an account. But if you just disentangle the two and say, okay, we have this pre-theoretical idea of indefiniteness that we have to accept in order to explain something, then you can just refer to existing work for the time being. And then at the later stage, you could, you know, give your own account. So that was just, you know, from the external point of view, it seems that it would be helpful to disentangle the two. But again, thanks. There were, I think, a finger from Lev and one from Aurélien. And then we could, yeah.
Lev, no? Oh, yeah.
No, I just, so for me, it wasn't clear, but I think Paul also kind of felt that it's not very clear. I don't understand. What does it mean? Object is colored when it has a color. And now you say object is colored, but it doesn't have a color. I don't understand it. Sorry, maybe I'm not a grand.
No, I'm not saying so. Maybe when I said that even my grandmother would understand it, I was exaggerating. I grant you. But although my grandmother is like who gave me the philosophical sort of attitude. So, but so let me say so. Sometimes when you talk about Lev, when you talk about you know. Words existing in degrees, so degrees of existence, I wouldn't say that we're really like, you know, distant from each other in thinking that we might want to accept some kind of indefiniteness, which is not something that you don't do, as far as I can see, at the level of degrees of existence in words. This is a proposal you have, you know, it's problematic. I'm not saying that it's the same thing. I'm just saying, what they share, what both my view and your view share, is this idea that the word itself might be somehow vague, either in degrees or in existence or properties, whatever you have. We seem to agree that this might be helpful in the sense that it might be helpful to change our metaphysical picture to allow for these weirdnesses in order to explain part of quantum mechanics. We agree on that, I believe. Then we might disagree on what's the best way to account for it. And here, it seems to me that at least, don't take it to like in the wrong way, but at least I'm trying to provide an account. Well, in some cases, degrees of existence, you know, there is no account even. Now you're saying my account doesn't work because it's crazy. And it is, I agree, it is crazy. But at least we can both agree on what is crazy exactly. Namely, it's crazy that determinable properties are not disjunction of determinates. Namely, red is not the disjunction of scarlet, crimson, and so on. Or being colored is not the disjunction of black, red, blue, blah, blah, blah. Usually people think that a color is simply a disjunction of the colors. I think, no, I think that we have to allow for the existence of determinables on top of determinates. This might be crazy, but at least I'm giving you exactly what we should disagree on. You see what I mean? And in the case, you know, it would be good in every case where we have some indeterminacy, some vagueness in existence. It would be good to exactly say precisely where the indeterminacy lies so that we could disagree. And that's, again, a suggestion for the account of vague in degrees of existence. Maybe you can even use my account. That would be nice.
Vague is one thing. Indeterminate, it's not vague. I don't think it's vague.
Well,
you say let's say we don't need many colors, black or white. So, or maybe black and so, let's say black, white, maybe some people really say it's not color. Red, green, and yellow. So then if we say that the object by definition is colored, then it has a property of color. Now you say, no, you want something special. You want to call it color, but you say it doesn't have a property of color. For me, it's just wrong definition. It's not vague. Vague, you say red, it's not exactly black.
I'm not saying that it's not color. I'm saying there is some echo, but yeah, whatever. So I'm saying that it is possible that objects are colored without a unique color. So they might be, this logically, this might entail two different things. It might have no color whatsoever, which I think is crazy, or it might have more than one, which I think is possible. More than one, for instance, is the idea that, you know, the electron that orbiting around a hydrogen atom, it has the determinable location, location or position, but it doesn't have a unique location or position. It has more than one. This doesn't seem so crazy to me once we believe in quantum mechanics. You know, it's a way to say what quantum mechanics is telling us. I'm not saying that it has no position whatsoever. I'm saying that it has more than one.
But just one reply. I think what people got, philosophers and maybe the whole human race, got from quantum mechanics that things have some uncertainty. And this, I think, is the biggest mistake. There is nothing uncertain about quantum mechanics. Everything is absolutely certain. And so uncertainty, this is a kind of no uncertainty. I don't want any uncertainty. What you say, we have, of course, we have delta X, delta P. What quantum mechanics tell us, forget about X and P. These are wrong concepts. So the wrong concept, of course, they might have bad properties. But if you don't talk about wrong proper concept, then everything is certain. If you say that the only concept is wave function, or if you want to be Bohmian, add to this position, everything is absolutely certain. There is no uncertainty whatsoever at least in my many words, and in Bohmian mechanics.
I agree on Bohmian mechanics. I think Paul would disagree on Everettian mechanics. I don't have a horse there. I would be happy if Paul is right. Don't take it personally, but because I would prefer that there is indeterminacy also there. But I think, you know, you read my paper, I think, which again, I thank you for the comment. I think in GRW, there is such a thing. I would just say two small things. I wouldn't say that, so usually philosophers are a bit, you know, annoying, but what they say is that vagueness is an instance of indeterminacy. So of course they are not the same thing, but in a way, vagueness belongs to a bigger family of what people call indefiniteness or indeterminacy. Uncertainty might be another kind, but uncertainty seems to be an epistemic notion. While when we talk about indeterminacy, we have some like ontological idea in mind. Of course, the indeterminacy could be epistemic. It might be indeterminate whether there is beer in the fridge, but just because I don't know. It's not that there is beer and there is no beer. In the case of electrons, we want to say, some people want to say that at least in some interpretations of quantum mechanics, it might be useful to believe that there is this ontological indefiniteness. And now I know that you don't like it, I know. But you know, I could say that it's as weird to believe that there are many words as to believe that there are, you know, indefinite objects. It's just to say that it's a price that some people might be willing to pay to explain some things, and as precisely as having many words is a price that other people might be willing to pay. And I'm not saying that it's not you know, worth paying this price. I'm saying that you have the motivations for many words, and there might be motivation for indefinite objects. That's what I'm saying. So
yeah, Christian. So in fact, a comment about that, which is related also, in fact, it was related to the Paul presentation, but I think the mini worlds can have a very clear ontology like in Bodmer mechanics. So there is no uncertainty in the sense of Niels Bohr or quantum logic or things like that. For example, in the presentation of Paul, he told me, we had a very nice discussion by him through many emails in a recent week about what he's discussing today. It's about this kind of generalization of Bohmian mechanics, many Bohmian mechanics, but maybe Bohmian mechanics is not the key here. It's the many history somehow, many threads or whatever. In that case, the ontology is extremely clear, and at least the advantage that I see in this theory is that you can make sense about probability in a very clean way. Because if you can solve the problem with Bohmian mechanics, then you can solve it for many Bohmian mechanics as well. Of course, I think it was Tony Sudbury who said before that I think it was a sentence of David Deutsch, say Bohmian mechanics is many words in a state of chronological or conical linear. I don't remember exactly the sentence. But I don't like this sentence because I had this discussion with David Deutsch many years ago, and I think for me it was the opposite. I would say that the many Bohmian mechanic is Bohmian mechanic in a state of quantum schizophrenia. So it's the two theories are very connected, very linked. The ontology is clear in both representations. But it's at least the advantage that I see in the many Bohmian picture compared to many discussion in the many worlds approach is that the notion of non-locality become clear for me, because Bohmian mechanics is non-local. This is, I think, nobody will doubt about it. So I think that many Bohmian mechanics is also necessarily non-local. And so it's very interesting because very often I can hear that the many worlds theory is local or something like that. There are a lot of papers about that, and for me it's very magical because I think they are confusing the non-signaling theorem, which is telling that of course you cannot communicate and faster than light, and Alice and Bob will not be able at the statistical level to communicate information faster than light, but at the fundamental and ontological level, the wave function is a non-local object. So it's especially in the many worlds theory where the wave function is fundamental. I think it's key to realize that you can build an ontology with non-locality in the many.
Yeah. I mean, I'd really like to just respond to that, or Helena, because I mean, the thing is, absolutely, wouldn't deny it for a moment. This wave function is fundamentally non-local. That's absolutely, and that's what I tried to stress earlier on. That in the scheme that I was sort of developing, there is that non-locality is there in the level of the environment. But where I think, and this is yet no, we're not in agreement on this. Where there's a difference, I think, is that the EPR Bell thing is specifically to do with entanglement, and and I think that is sort of an entanglement non-locality can be, or the locality can be preserved in the many threads theory, because in the way that I've portrayed it, because of the way the subject is related to the environment, and the fact that, in the classic Alice and Bob situation, they just split. Nobody has a definite out. The intuition has been around for a long time that the EPR sort of Bell non-locality, it depends on having a one-world theory, and that if you've got a many-world theory where you've got fission, where you've got the subject splitting, then there's nothing that no outcome that Alice gets which tells you anything about what Bob gets at space-like separation. Bob's going to split like Alice is. So it does seem to me that that entanglement non-locality is got rid of in exactly the way that I think Lev totally agrees with that. That what he says, it's not, there's not action at a distance sort of non-locality, but he admits that there is a sort of locality. I would think that, you know, that's the non-locality of the wave function. But
so this different level of ontology, it's possible to understand that. It's like if you speak about hidden variable, you say because it's hidden because you cannot see this non-locality statistically. You cannot use it. So
yeah.
for an observer like you and me, it will be not possible to use it. So I think we are telling the same. We are probably speaking about the same thing.
Well, maybe that's part. Maybe we're saying the same thing in different ways. I don't know. Yeah, need to think about it.
And yes, and last remark about this thing is about the consistent story interpretation.
Wait, sorry, Aurélien, because
yes.
I think Lev might have a finger. So before you move on,
sorry, excuse me.
Just to make clear, you're trying to say that the Bohm and many words are similar in non-locality. Many words is non-local, it's not separable, and we have this entanglement. But it does not have action at a distance. And Bohm has explicitly action at a distance. So action at a distance, instead of non-locality, kind of a very general form. What is really bothers me in nature, existence of action at a distance. And this is why many words for me is so attractive. It does not have action at a distance.
You should distinguish between different ontology, I guess, because the many words and the many threads, I think, are different things. In a sense, they are common structure, but at least in a many Bohmian, many threads, whatever, since you are simply multiplying Bohmian mechanic many times, I think if non-locality is present in one, it should be present, simply multiplied many times, so it's still here. But I agree that in your version of Bohmian mechanic, it seems that your image is frozen. No, it's okay. Yeah, in Bohmian mechanic, it seems that it's different theory. Yeah. It's we should. I think you have enough space for putting different name and different theory, and it's not the same, I guess.
Lev, may I have a follow up there, because so we were there. I think you were there when Tim presented, and Tim has this idea, you know, that that really, like, the distinction between action or passion at a distance doesn't really cut much ice, as people say. So I was wondering, I think, you know, you seem to rely on this distinction, and of course, like, you know, I like GRW, so GRW also people say doesn't have action at a distance, but only passion at a distance, like precisely like many words, and differently from Bohmian mechanics. People also have this non-separability, non-locality distinction, or outcome, violation of outcome and parameter independence. So there are a bunch of distinctions there. What I want to know is, yeah, were you saying something? You're muted. I just wanted to know your idea about what the team was saying, because it seems to be slightly, you know, in conflict with what you're saying. It seemed to have good motivation for believing that there is no, like, genuine distinctions there, as far as we don't confuse violation of locality with violation of no signaling, which are not possible in Bohm either. So I would be happy if there exists such a distinction as a defender of GRW, but I'm just not sure whether there is any. I think I'm quite convinced by Tim on this.
If I remember discussion with Tim, I think he was more or less replying to my concern that I was trying to persuade the same message, that many words is the only interpretation without action at a distance. Now in Bohm, kind of everyone agree. If I have, for example, EPR, entangled EPR pair, and so I decide to measure on one side and not to measure on one side, this will change actual result on the other side. So, but it's I cannot make signaling because they're hidden from the beginning, so no problem. And in GRW also, there is action at a distance. If I have a particle in a superposition of two places far away, if I don't touch any one of these parts, then the GRW jump probably will not happen for the next 10 to the 5 years. So the wave function here will remain to be, let's say, half or third. But if I will measure it here now, I will force it to collapse to 0 or to 1. Mm-hmm. So I can decide to change the wave function here. Since this forcing is probabilistic, I cannot force to 0 or to 1. It's with probability, with right probability will go to 1 or 0. I cannot send signals, but I can change the reality on the right side with GRW. I cannot do anything of the kind in many words. As Paul said, whatever I measure here or not measure here, the reality of all words together on the other side will not change. We have the same local density matrix description. So this is what the meaning no action at a distance. And Tim, I think, was kind of, I don't know, he said that maybe, he still thinks that it's kind of strange, whatever, but he may think that he cannot understand how you can, this is what discussion was before, how we can talk about the wave function of the universe and not to think about it only in configuration space. Mm-hmm. And then I say, because I don't want to add any variables whatsoever. I think it's unnecessary. The fact that John Bell wanted it doesn't make it true. Doesn't make people follow it. It's true, but it's not necessarily that people should have to follow it. I think that we have this many words which he never understood, which is a beautiful theory without any addition. And this addition, these are these variables, and I think it's not so simple, but we can find correspondence to our experience without variables. So I look at this big wave function and I find structures which are similar to what I see around, without calling them variables. This other theory, primitive ontology, whatever, they want to make life easy to how to connect to my experience. They put this ontology, variables, Bohmian positions, and then it's very easy to see a cat. There are many points in the form of the cat. Now I have more difficulty to see a cat because it's just this wave function and it generates in configuration space. And then I say, oh, even macroscopic object in a world wave function have this part describing the macroscopic part in 3 dimensions. So I do get the shape of a cat. If I draw this, for some, Bohmian called it GRW, I want to call this mass density. Mass density is just, you take the wave function and you can derive this property. It's a property of the wave function. You don't need to add any ontology of this mass density. It's just property of your wave function. And this can be calculated from the wave function. So you'll see a cat. I see a cat, I find the correspondence to a cat. And I don't need any additional ontology beyond the wave function.
I think you've been quite unfair because that was the topic of discussion for the next half an hour. But now we are forced to, that's the topic I wanted to discuss. But if you don't mind, can we pause for like 5 minutes on this and then come back before maybe there was still another issue and Paul wanted to reply. And then I think we can dedicate the last time, the time we have on this issue. I would like to. But first, one actually very small follow-up on what you were saying. You were sort of saying about GRW and Bohm that there is this similarity about acting at distance, right? But I was sort of puzzled because you were saying if I make a collapse here, if I make some particle collapse here, I will thereby make the distant portion of the wave function also collapsing, which is true, but it's weird that you're using, it's just a clarification. It's just weird to me that you're using, I will make the particle collapse because, in GRW, you're not making anything. It collapses.
I tell you what, I'll explain what I mean. First, I think both have action at a distance, but of very different kind. So there's no big similarity. It's different action at a distance. when I perform, for example, this measurement in Bohmian case, immediately nothing will change to another particle. I will have to wait because the equation of the velocity will change and the change of Bohmian position will happen only later. In GRW, this will happen immediately if you believe in kind of non-relativistic collapse. Now, what do I mean by I will force the collapse? What I mean that I had this one particle half here and half here. In one case, I don't touch it. In another case, I bring a big measuring device which measures it. And then because of the measure of this operation of measurement, then there are many involved, and there will at least one GRW hit for my measuring device will happen, and this will collapse the other particle.
In this
so
sense,
this is how I collapse. I do it by action. I perform a measurement. If I perform a measurement here, I will force collapse because when a measurement, I will make entanglement of this particle with many other particles, and at least one of them will make GRW kick because there are many particles. And in this way, I will change the wave function parameter.
Okay, that's helpful. It's what I had in mind now. I like that. On the instantaneousness, you know that in relativistic versions, actually, that's not instantaneous, but you know, it's in the future light cone. You know that more than I do, but that doesn't change it. So I agree that. I mean, on Tumulka and Vaidman stuff, they seem to have
Tumulka made relativistic formal things, but even he has. It's only on the level of flashes.
Yeah.
His wave function changes not relativistically. Only flashes, they fulfill the relativity. But now they say that the wave function is not ontology. It's like some Bohmians don't like to take the wave function of ontology. I think it's very problematic. And the law should be so complicated. So to take the wave function as non-ontology is, I think, formally you can do it, but it's, again, it's also non-local law in this case. So then only your kind of flashes happen relativistically, but I don't think it's as much.
I think the prospects on the Vaidman proposal are better, but I'm not going to spoil anything on this, and we're not going to waste time on this because I plan on having Vaidman himself at some point, so maybe we can come back to this.
Sorry, can I make a short point?
Of course, Dustin.
Yeah. Hi. So my just a brief point. So what also in many worlds changes non-locally in EPR type experiments, right? Other prefactors, or what Lev would call the measure of existence of these branches, right? And then one can say that they don't have no physical significance, so this change makes no physical difference, right? But then if they are physically meaningless, they can play a role in describing or in justifying the Born rule. So, and when it comes to the issue of probability, then all of a sudden Everestians try to argue that these prefactors, they have a significance, and they have even an empirical significance. So I find this always a bit, I want to say dishonest, but I don't mean it in a personal way, that, they are either meaningful or meaningless, regardless of, depending on what one wants to argue for.
That's it. There is a Bob far away. And you want to say there are all kinds of branches, his branches. I cannot change the measure of existence of his branches, whatever I will do.
Yes.
I can change, I can decide how many words, because the words are kind of all over. And then for this non-local concept, I can change something. But for Bob, including the measure of existence of his branches, for him, so he lives in several, at least it will take average words. I cannot change average words of Bob in any way whatsoever if I'm not near Bob. Nothing. So nothing, Bob far away, I have an EPR, whatever I'll do here, I will change nothing whatsoever for Bob. Nothing. Again, nothing if I'll take all words together. This is the whole point. Physics describe all words together. we kind of feel we are conscious creatures which happen to evolve being in particular worlds and see kind of illusion of all kind of non-locality, randomness, and other things. But if I'm kind of outside and even inside, I understood the nature. And the nature is deterministic and without action at a distance. Whatever I do here, I will change nothing whatsoever. What you had some other example in mind, but well, you said that when my measure of distance changed. Well, what do you mean by that?
Well, you have the non-local correlations between the different branches of the wave function, and depending on, you have different branches of the wave function, right? They are non-locally entangled.
I can create them. Yeah. Good.
Yeah, and my parameter choices, or Alice's parameter choices, they do influence the what you would call measure of existence of the corresponding branches for Bob.
No. Again, the branches defined by macroscopic object of, let's say, Alice and Bob. So Bob performs some measurement up, down, and he has his words with upward, downward, and whatever. Alice cannot change this amplitude in any way whatsoever. She can, if outside, we're now talking about different branches. Bob up, Alice down. Bob up, Alice up. We look on all of them, on a set of them, then Alice can play. She can measure in the same direction, so it will be 2 words. She can measure in the other direction, it will be 4 words, because for each Bob word, there will be 2 Alice's words. So the kind of, if we talk about the words altogether outside of Bob, but if with Bob, if we use Everett language, maybe not my language, but words relative to Everett, Alice can change nothing whatsoever. Bob will have words with his definite outcomes, and Alice cannot change the weight of this outcome.
Okay, but then let's just take what you are saying. If they measure in the same direction, there will be 2 worlds, and if they measure in different directions, then there will be 4 worlds, right? And
Correct.
It's still true that if Alice had measured in a different direction, right, then there would be 2 copies of Bob instead of 4. Why is that not a physical difference?
No. This is what's the mistake of Sebens and Carroll. When Alice measures and nothing comes to Bob, there is still only 1 copy of Bob. This copy lives in 2 words, but there is 1 copy. To say there are 2 copies is just to write A plus B times C, open parentheses, and now to say there are now 2 Bobs because you write it twice. But this is kind of, for me, it's really ridiculous. I'm sorry that I use this word.
Yeah, but then it's still a different, a physical difference if Bob coexists with 2 copies of Alice or with 1.
Yes, there are. Bob Bob exists in the world with Alice up, and Bob lives in the copy with Alice Bob. But it's the same Bob. There is only 1 copy of Bob, and you cannot. The Alice is different. Bob is not. You cannot ask what is the probability. They ask what is the probability that the Bob in Alice is upward. It's meaningless. The same like meaningless in many words. You cannot ask what is the probability of the outcome of the future experiment. No, because it all will happen. And here's the same, Bob in both. So you cannot ask this question. It makes no meaning.
Okay, but can I ask how many copies of Alice coexist with Bob in this world?
How many what?
How many copies of Alice? How many Alices coexist in Bob's world?
If Alice, let's say Bob doesn't do anything, Alice measures. So now there are 2 Alices. If Bob knows that Alice in particular time and perform measurement, he knows that there are 2 Alices. And he make another measurement, it's still only 2 different Alices. If she measures one measurement, she splits only 2 different Alices, 1 up, 1 down.
But if let's say Alice measures in spin in Z direction, and Bob also measures in Z direction, then each copy of Bob will coexist with 1 copy of Alice.
The word will be the same. So
right. Right. But had Alice measured in X direction, then if I understand correctly, each copy of Alice would coexist with 2 copies of Bob.
Yes, it's true.
Why is this not? Then why is this not a physical difference?
It's a physical difference. It's not a physical local difference. Locally, for Bob, nothing. Whatever Bob Alice measures this way or other way, nothing changed. Of course, if we talk about correlation between different things, and we did something different in A, so of course there are different correlations. A correlated to B. Now you perform, you rotate A or not rotate A. So it's of course correlation between A and B change. But this is also local, no action at a distance whatsoever. You changed nothing in B. You change, of course, if you have correlation between A and B and you change in one of them, then this non-local property change. But the local property, when you do something local in Alice, local property in B will not change whatsoever.
Well, I don't know, maybe it's a semantic disagreement, but it seems to me that there's a non-local change here. If whether in space-time region B, there are 2 or 4 copies of Alice, or whether in one world with Bob, in the distant regions, there are 1 or 2 copies of Alice. That sounds like a physical difference that is non-locally influenced by the parameter change.
There is a maybe the finger from Aurélien will.
In fact, it's really correlated to say what says Dustin and Lev. I think I agree completely with what says Dustin, because the thing is that in the many worlds theory, even though Alice and Bob have only local information at the end, there is a wave function connecting Alice and Bob, and so even though Alice is not knowing what is happening on the side of Bob, it doesn't matter. It's only because you focus on local quantity. But the many worlds theory is a wave, so the wave is a solution of Schrödinger equation, and the local property are only a part of the information, but it's a reduced information. You make a class on all the degree of freedom that you don't want to care, and you say it should be only about this local information. But no, the many worlds theory is non-local, because the full Hilbert space is mixing is mixing everything. So the wave function is, I call it the web function, because it's connecting different variables. So in fact, I would like to show you something. If I can share my screen, partage screen. Wait a second. Touch. I don't know if you can see. I don't know if you can see what I'm partaging. I'm sharing here. You can see?
Yeah.
So yeah. The thing is the following. It's I have only one slide. In fact, I wanted to show you very quickly. If I can put it in a print mode, full screen. Yeah, it's better. Yeah. So my point is the following. If you consider the many worlds theory for a single particle, what we call a single particle, I would say that for a single electron, let's say, it will be simply the original Schrödinger theory of 1926. So in that picture, it's a classical theory, like Maxwell theory. So you have a space which has the physical space. For example, for us, you know that you have three dimensions, but maybe let's consider one dimension because graphically it's easier. So the universe has one dimension, and for one electron, so you have only one function, C of x. And then in that case, you have electron fluid, you have a different representation of the problem, like Madelung hydrodynamic representation, for example, which is used also in Brownian mechanics. But now, if you want to go to the problem of quantum mechanics, you need more than one electron. So if you can have two electrons, one will be the measure system, and the second one the observer. So for me, it's you have already two systems, so you're already a universe, complete system is good. So in that case, the postulate of many worlds theory, and this is the ontology, is that you should describe the theory with a function of different variable. So in that case, it's a generalization of the classical Maxwell equation or a classical picture that you have in field theory in the 19th century. So since it is a correlation, it's also implied that you cannot represent it easily in a three-dimensional space or in a physical space. You need probably the configuration space. But since I don't believe that the configuration space is a physical object, it's only a mathematical tool, I prefer to say that it's a correlation function. So if you have 2 points in your physical space, now here 3 dimension, you can correlate these 2 points, but the points are not particles, like in quantum mechanics. They are really points, and you have a correlation between these points. And for me, when you say that you say that the theory is local, or that you cannot have action at a distance, it only means that you average on some information.
No.
But then it's not fundamentally, the ontology is not local, fundamentally. It's only an illusion that is local.
Well, I agree. The wave function is non-local, but it does not have action at a distance. The idea is you have this description. Now you introduce a hypothetical situation that somebody comes to a point A and perform something external. Will we see any change whatsoever in B? In many words, we will not. In bomb, we will, and in GRW, we will. In many words, nothing whatsoever will happen in B. Nothing.
Okay.
Depending on what. Yeah. Sorry, just depending on what Alice measures in New York, according to what you said, there could be 2 or 4 bobs in Tokyo. Why is this not a non-local difference?
No. For example, it might be no. If Bob doesn't do anything, and it was 1 bob, Alice cannot make 2 bobs. It still will be 1 bob. She cannot change the number of bobs. To make 2 different bobs, Bob has to perform quantum measurement. If he doesn't perform quantum measurement, the number of bobs remain 1.
This is because you focus on local information.
So of course, action at a distance can be described only by a local. Action at a distance, that something happened in a local region.
And it's a problem of semantic.
If you talk about non-local properties, of course they have non-local equation. The question of action at a distance, you can talk only about local property. Does local property somewhere changes when you do some local intervention somewhere far away? This is a question of action at a distance. Okay,
but this is for the ontology, but everything only will make sense if you have interpretation of probability anyway. Because it's these 2 questions.
You cannot check probability. First, there is no probability in many words. Doesn't exist. Everything is deterministic. But even all kind of you can introduce this illusion by special situation when you don't know in which world you are, and even this cannot be changed non-locally. If somebody performs this special experiment when he has this illusion of probability because he doesn't know in which world he are, he cannot. Somebody far away cannot do anything with it.
Okay.
Sorry, Renat. Sorry. We can come back to this. There is also another finger on this point. Then I'm going to sort of wrap up because I don't know how much time we still have.
Yes, you're right.
I'll try to let everyone say what they want to say, but it's unlikely that we can. So the finger was from Baptiste. And then if both Aurélien, Dustin, and Lev wants to have a small comment on this, just try to be quick so that we can move on. So Baptiste, Dustin, Aurélien, Lev.
Hi, everyone. Just a small point, as I think I have the feeling that Aurélien and Lev are basically passing each other. I mean, there is less disagreement than what they seem to think. I mean, I think it's quite useful to use, for instance, the terminology used by David Wallace. So you have non-locality as a generic phenomenon, and then action at a distance and non-separability can be seen as 2 different possible sorts of non-locality. And what Lev is saying is that in the many worlds view, you just have non-locality, but you don't have you just have non-separability, but you don't have action at a distance. And I think it makes a quite substantial difference, right? And I mean, I guess the view in the manual view is that you have a full space, you have all the branches, right? So of course you cannot replace a branch by another branch, right? You just have the multiverse, which is there. So you don't have a notion of someone acting somewhere and manifesting something elsewhere. But you still have this correlation function that Aurélien mentioned between everything, because the wave function is defined against the configuration space. But this non-separability of the quantum state or the wave function is not really like an action somewhere acting on something else. It's more like the job done by, it's the structure of the wave function itself, of the multiverse. So it seems to make the difference, to me at least, between action at a distance and non-separability, or a weaker form of non-locality. So yeah, I guess I was trying to say, yeah.
Yes.
Hope I was clear.
No, that was very clear. Thanks for this point. I would have also a point there, but now I don't want. So maybe Dustin also has a similar point to mine. I don't know, Dustin, if you want to say something. I don't want to push you, but maybe.
I would yield my time to Jean, because it felt like he would.
Okay. I didn't
and
see.
I think he.
Oh, sorry,
Yeah.
John. I didn't see that you had a hand there. You can go, but you are muted. So maybe unmute yourself first, and then you can.
It's not very, yeah, it's not very important. But I would like to ask, since we seem to have definite copies of Lev in future worlds, and we say that the future is determined and every possibility occurs, then I would like to know if there is an experiment with possibilities 9, 10, with two different outcomes, probability 9, 10, and 110. Then how many copies of Levs are there? 2 with different degrees of existence, or 10, 9 in one situation and 1 in the other situation? That's a definite question to which I would like to have, an answer. Of course, I don't understand what degree of existence means, but since last week, it was brought up this possibility that you might think of having 10 worlds, 9 in one type and 1 in the other type. I would like to have a clear idea about how many worlds there are, how many copies of you there are, if you wish. That's one question.
So I can answer, yes?
Yes.
So, but maybe Uriel, you had some slide about my Stern-Gerlach experiment, you remember?
Yes.
Can you show it?
Yes, no problem. Wait, if I can, yes. Yes.
So
I modify a bit, sorry, because
what?
I modify a bit the slide, but your picture.
But if I understand correctly, this is a Stern-Gerlach experiment, correct? With when we have the chance, the standard quantum mechanics, I don't know. Let's say
2/5 and 3/5.
2/5 and 3/5. So if I will put my detector immediately after, so I will get either this outcome or this outcome. This is kind of my complicated detector. But if I will put instead just kind of detector here and here, first I will say there will be 2 of me. One get up and one get, this is minus 18, and one get down. And I will say that the measure of existence of is different. 2 different levels. One outcome, other outcome. The number of levels is number of different stories. And there is one level which got up and one level which got down. Now, I also add this kind of things, which it's not kind of a proof here, it's derivation, but anyway, this is not part of the derivation. This is why I think I have to postulate that, let's say, if I perform this experiment with my trick of sleeping pill, that I perform this experiment and I move to one room in another room, and then I'm awakened and ask which room you are. And I know everything. I know that there are 2 rooms, and I live in one world, another world, and But then I will say that I have to postulate, and this is a different additional postulate of nature, that I will bet that I am in a world, let's say 2/3, and this is 2 and this is 3, 2/5 and 3/5, that I will bet on this as 2/5 and this 3/5. And this picture explains why it's plausible, this postulate, because I can kind of separate it to make more separation. Measure not here, but measure exactly here and here. Here, for example, now there are essentially 5 detectors. It can be here, here, five detectors. So there will be 5 words later. The property of these 5 words, they will all have the same, measure of existence. Then I think when words have the same measure of existence, it's natural to bet them in the same way, like if somebody will split me in 5 copies classically. So the answer to your first question, after simple measurement, there will be just 2. After this measurement, there will be 5. 2 with up and 3 with down.
Okay, so the measure of existence is defined counterfactually by saying that you could measure different things and then you would get different, a different number of words. Yes.
No. The measure of existence is just I will look on the amplitude and make it square. The measure of existence proportional to this standard average measure. I don't have to do this.
No, I know, but to give meaning to it, which I still have no idea what it means.
The main meaning which I give for it, let's say I got this 2 or I get this 3. And then I have this story about super technology, that somebody come to me and says that now I'm from another galaxy and I have super technology which can perform experiment of type of a Wegener. So, but I'm bored and I like make bets. So let's make another bet. You have the Stern Gerlach, it can go here. Let's bet on this experiment of what outcome will come out. So if I'm the one with this one, I will say, he can cheat me, because when we will make this experiment together, he has a technology to take my other part and spoil the interference. I think it should be 2 to 3, but bringing another one, he can change the interference. He can bring another me and change my odds. But I will say that if it's 2 to 3, he can change my interference less than if I'm this one. So it's important for me, my measure of existence tell me how strongly I can interfere in the future, and how strongly this creature can interfere with me and spoil my experiment. I believe that I perform the experiment and should get particular odds, but the creature can change it, taking me the other me. So the power of interference, the measure of existence is power of interference if there is a technology to interfere different words.
Okay. Well, I still think that there's a sense in which, as I agree with Dustin, that there is action at a distance because you create less or more words. Of course, you don't call it action, but then of course, in Boom, you can also say there is no action because there is no transmission of messages or anything. You just change the situation just the same way you do in many words. You create more words in many words, and in Boom, you will have different results if you have not done something on one side. If you do something on one side, then you can have a different result on the other side. But it's all, of course, counterfactual reasoning. So there's a sense in which you can say, well, there is no real action. But okay, I think that's a matter of terminology more than.
No. May I say where you see the difference? In Bohm, the ontology, definitely, no one will say, some people say that wave function may be not ontology, but everyone will say that the Bohmian positions is ontology.
Sure.
Now, what?
Sure.
And this I can change remotely. Sure. Now, in many words, I say the only ontology is a wave function, not words. Words are not ontology. It's my concept which helped me to connect the ontology to my experience. This is just kind of like, this is not ontology. And so the wave function, the local wave function, in Bob's side will not change whatever I do in Alice's side.
Yeah,
The moment position on Bob's side will change whatever Alice will do on her side. Therefore, in Bob, there is action at a distance on the level of ontology, and in many words, there is no action at a distance because I do not change ontology by action in faraway region.
Well, I don't really agree with that, but you do. You see, the problem is that to me, of course, the whole thing of the pure wave function ontology doesn't make any sense. So there's no space-time, and then of course everything.
No. Space. Everything is space-time. My wave function in 3D. Everything. It's also entangled, and there are some entangled things. The wave function, space-time is given. Without space-time, I don't think I understand what's going on. I have a 3D. All particles are in 3D. They also have some spins, which are discrete variables. But of course, the wave function in 3D. I have a space-time, it's part of it. It's not, I don't like language, of course. To make mathematics proper, I will use Hilbert space, whatever. But the space, the physical space, is 3D. One 3D.
The wave function is not defined in 3D, but in 3n dimension, if n particles. But anyway, we have to agree to disagree. But let me simply say that I think if you want to make a well-defined many worlds, then you can do many worlds with continuous matter density like Allori and others did. And then, of course, in that thing, it's pretty well defined. And there you can actually prove that the theory is non-local as it should. Because of
No. I cannot change this density.
There you can. In the paper of Allori et al., they discuss it and they show why it's not local. But of course, they have more ontology than you because the pure wave function ontology, I don't understand even what it means.
But mass density, I cannot change mass density. I cannot change mass density in the Bob side by operation analysis side. Mass density is my ontology. As I call it mass density, it's a property of the wave function. Mass density is local, not in configuration. It's local.
Look at their paper. I forget how it works, but in their paper, they definitely show that you change, you have a non-local, you have an action at a distance. Maybe Dustin remembers that paper better than
I don't know which paper you're talking about. I'm sure I can bet. No way to change local property of wave.
So it's a paper of Allori and Goldstein and Dürr. I forget it. No, not Dürr, but maybe Zangi and Tumulka. I don't know. There are several authors. I can find it in my book. But
you mean the Schrödinger many words?
Yeah, the Schrödinger's first theory. Yes.
Yes. No, it's the same. No change. You cannot change. No way. That you cannot. Whatever you do in Alice, you will not change anything there because essentially what they say it's many words. The Schrödinger probably historically probably saw the Everett picture before. He just thought it's absurd and he didn't push it forward. But this showed, and I have some other. I read some other paper by Schrödinger that I think he understood many words, but he saw that it's so crazy, so he didn't.
Okay,
say it loud.
We'll have to agree to disagree because you can go back to that paper. Maybe Dustin can explain it. I forget the detail of the proof, but we have only 4 more minutes, so I should stop.
I think the difference might lie simply in the fact that one thing is wave function monism being non-local, and one thing is many words being non-local. I think the version Valia Allori have in mind is clearly not wave function realism, wave function monism or realism.
No, it's not.
So in this sense, they achieve a result which is probably what people would expect. But then the difference seems to be that what Lev talks about is not really the many words, but really what's non-local is this wave function all is psi, which can be disentangled from many words as far as I can see, right? So what is non-local is the ontology of wave function only ontology. This is non-local. Which again, it's fine for me because I don't know what it is. So I cannot.
It is non-local.
Sorry.
Well,
one wave function ontology. This is many words.
Sorry,
you say this is non-local.
Well, look at the paper. Destin just send this to us, but we don't have time to discuss it today. I think
we could have Valia telling us something. Maybe I'll ask her. That would be a nice thing to do next year. Anyway, I already invited Valia. Probably she wants to talk about something else, but maybe we can also have a meeting about this issue because it seems crucial. So we have 3 minutes now, and so many things we are supposed to do, but since we will never be able to finish anything, I think I'm going to allow some people that didn't speak so far, if there are any, if they want to ask some question, let me know, raise your hand or move.
Well, maybe Aurélien has not said everything he wants to say, but.
And yeah, and then
probability, but it's a complicated topic, and this is
if there is nobody else, I would probably allow. Yeah, there doesn't seem to be anyone else. So I will let Aurélien, if you can make.
Very quickly, then. No. It was the continuation of the slides that I took from the article of Lev. The point for me is that I understood really recently the content of this paper, which was very, very curious because I didn't realize before that it was like that. But this paper says somehow that if you want to interpret the measure of existence of the degree of reality, whatever you want to call it, as something linked to statistics, then you have to do this kind of trick that it was originally proposed by Zurek in 1998. For different interpretation, doesn't matter, but the trick is to make some fine graining on the wave function.
Just David Deutsch before.
Yeah, but actually the paper is 98, so I think Zurek is before. It doesn't matter.
It's matter. It's really matter. I discussed it with Zurek.
Oh, okay.
And then never heard about any mentioning of this later. So it's really, I don't like to put credit to him, which was definitely written in the David Deutsch paper.
He told me the opposite. Okay, so the thing is that, anyway, what I found curious is that you need to have this device in order to transform the branch into a large number of equiprobable branch with equal weight. If you don't do that, it doesn't work. So
what do you mean doesn't work?
I mean, if you don't do it, you mentioned it in your paper. You said that if you don't do this kind of division into sub branches, you are not able to give a proof of Born rules. Because
no, it's not a proof. In this way, just consistency. That if you want to have a proof like classical thing, you want to say number of words. The standard kind of thing, if you want to consider the number of words, which I don't think it's needed, but if you want to make the proof like classical one with the number of words, then you have to do this trick. But you don't have to do this.
But if you don't do it, you don't have a consistent theory, I think. If you do it, you have a consistent theory.
My proof of Born rule is before. It's from relativistic causality and symmetry, and has nothing to do with this. This is just a remark that if you want to have some similar situation with classical counting argument about number of, and usually when in combinatorics you count different numbers, and then and in this way you make statistics. If you want to make this argument, then the words should be of equal weight. Otherwise, it doesn't work.
That is your interpretation of it, but I saw it. I used your picture, but I think that it has a different meaning, because if you don't have this branch counting, it doesn't work for me, and so it means that your theory is super deterministic.
What?
Super deterministic. So it's even worse than non-locality.
And again, this is just, it's not, before this, there is a proof, which I also say it doesn't worth too much, because I make assumption.
Yeah.
I make assumption of relativity and symmetry, which I think is very natural. So the main assumption is relativistic causality. So therefore, there is no proof, because without assumption. And this is kind of other things. This is not related to the proof. It's just related that if you want kind of similar picture to get kind of the intuitive nature, like what happened. Here there is a splitting to number of words. You can Parfit and others, and Derek Parfit and others, or Elga playing with all kind of ideas, how to make splitting classically. You make copies and others. So to make connection to this kind of thing, then I can say that if I will make all words of equal weights, then it works the same way like classical. but I never consider it as a proof, and it's not essential and not anything. But my meaning measure of existence is power of interference, and also this the experimental fact that this idea that my probability to find myself in this world, it's also, you can consider it as an experimental fact. All what I know about my quantum experiment, I find myself that I find born statistics. This is experimental fact. So I can postulate essentially in all quantum interpretation, Born rule is postulated.
But this is the point.
Everett and Deutsch, I think erroneously, was trying to say that they can prove it from nothing.
Yeah, it's different topic. This is the topic of Dutch, it's direct, it's different thing. But if you say that you want to add this idea in order to be in agreement with experimental fact, it means that you add something in the theory, which is not necessarily in contradiction with the theory, but you add something, and this thing that you are adding, I think, is superdeterminism. Meaning that if you don't add this division of the branch, it doesn't work.
The counting argument doesn't work if I don't do it, but counting argument was not supposed to, because there is no reason whatsoever to say that two words should be on equal footing.
But you need statistics at the end, so it's the reason why you need
This is the wrong way to make statistics. You perform experiment, something with probability 0.1 and 99.99, and then now there are two words. And why would you consider them on equal footing? This is very strange.
Yeah, but so if this prefactor means something, this an ability of interference, then it can change non-locally. So my point that I wanted to make initially is that you can't have it both ways.
No, you cannot change it non-locally. This is locally. You see, I locally split here all this and made additional in this branch. In this place, I make additional splitting. I made more, I put these detectors. Here I put 2 detectors, here I put 3 detectors. In this way, I arranged that now equal weights. That everything is locally. Whatever I put detectors here will change nothing far away if they entangle. So this change only make only local change.
Yeah, but maybe it does an EPR type experiments. The parameter choice of one experimenter has an influence on the splitting and the relative weights of the branches that include the
non-local branches. If I look on words all together, then of course, as I said, I can split to 2 words, to 4 words, or in GHZ, I can also play up to 8 words or just 2 words. By different, we can define GHZ, people can play and create 2 words, 4 words, or 8 words, depending what they measure. So there are different global stories because every time macroscopic objects are different, so it's more words. But again, you can, whatever Alice and Bob do, they will not change anything on Charlie. The Charlie's reality remains the same. So global reality different. Of course, global reality change.
I have to stop you there. I think, probably you agree more than, as far as I can see, you agree more than it seems. I mean, one thing is non-locality within a brand, within a word. One thing is across them, right? So it seems that within words, of course, you don't have non-locality because you have more than one. And in BOM, of course, if you have anything, it's within one word because you have just one. So I don't really see how much there is disagreement there. If you have one word, of course, you can have no locality. You cannot have no locality across words.
Words are not the issue. I'm a physicist. Physicists describe nature. Nature describes all words together. Equations describe all words together. So on physics equation, action at a distance not acceptable. Inside word, this is our concept. This is, this is different story. Word is not a physical concept. Word is our concept of conscious being to discuss.
It's another issue. Now you're giving motivation for preferring non-locality across words to non-locality within words. You're giving a methodological motivation. but I'm sure that Dustin has different motivations for the other thing. So, and I think it's 5, so it's 5, 10. So it's hard now to settle which methodological motivation is to be preferred. So we can run out of time a tiny bit, but not too much. So I would like to have Lev and Paul have the last words. And I'm sorry if someone else wanted to ask further questions, but I think this is fair. I would ask you again, we're already running a lot late. So if you can, you know, it would be nice if you want to give some final words. I don't know, we can start from Lev and then Paul.
I don't know, I think reacting on other people, although I didn't, you asked me final words, I did. First you asked me to prepare some additional things, which I never did it. So maybe there is only one.
I'm so sorry, I thought you didn't. I really thought you didn't prepare anything more. I'm really sorry about that.
No, first I have few slides which I didn't have time for them. But really, just a small remark on.
I would be happy to give you some time, and I would be happy to listen and stay. If anyone wants to leave, I'm sorry for this confusion.
I had an answer the last time. Did you see what I shared with you?
Not yet.
No? You don't see it? I think I shared, but maybe I didn't. Let me make share.
Yeah, now
yes, it's starting. Yes, it's sharing.
Yes, let me try this. Okay, it was this slide, and I gave some answer which I kind of agreed that I'm complaining, and I just want to make a small. I think it's also relevant to what we discussed now. So this is kind of my picture of the reality. I think the reality, it's only the wave function. And what's important, it's the case when there is only one word for some reason, because no one performed quantum measurement to split them. And so I was trying, and I'm still saying, that this one word is the same like in Bohm or in GRW or in classical physics. It's very much the same. And then I had, first, the main reason, because when I consider this macroscopic object, they really, in 3 dimension in the product state, well-localized packets of everything. So if I look on tail or nail of a cat or something, so it's just in 3 space, whatever global variable describing position of a nail I will find, it's really kind of very localized wave packet in 3 dimensions. There are some entangled things with microparticles, electron protons, but if cat, when he doesn't catch the mouse with them, it uses nails. And the macroscopic things are live in 3 dimensions. And just then I was telling that the Bohmian position, this is kind of particle, sitting inside the wave packet of the wave, and then I kind of agreed that this is not exact picture. It is not exact picture when I consider free particles. For free particles, I really don't have a theory, and they're only in the rest, and they're not described well by this story. But to see the reality, I need this macroscopic object. So if I look on particles of this object, they not look like this. It's kind of a lattice. And in this lattice, I think this will be still correct. In this lattice, all these molecules will have this localized wave packet and Bohmian particles inside. Outside, in the free particles, this picture is not correct. And this picture looks like not lattice, so it's not, maybe it's misleading. But if I have kind of a solid body, in a solid body, I have electrons which are everywhere, and it may be not important. But nuclear are kind of well localized. And they well localized as wave packet or well localized as Bohmian position. It's the same, this well localization of GRW will be to the same thing like my single word of many words. So this is what I wanted. I'm still with you?
Yeah. Thank you.
Okay.
I'm sorry if I didn't give you more time for this, and I'm also very sorry that we didn't have time to discuss another issue that I really care about, which is this reduction from the wave function that is related to that, of course. I hope I don't need to say again how happy I would be if you both join us together. I mean the author now, but also the audience, to discuss this issue further. And if you want to suggest any changes to the program, when I will send you the program, if you want to add topics you want to discuss, it's really like I don't want to be in charge. I would just really want to decide together what we discuss. So it would be nice to come back to some of these issues and next year. So yeah, now again, if you want to say something like, some final notes that makes everyone happy and everyone agree, I think this would be harder for Lev than for Paul, but I think you can both try.
I think only disagreement can push science forward. I'm not looking for agreement.
Here you go, you did it. Well done. Okay. Good point.
Well, I'll say, I absolutely agree with that, and it's been extremely useful, and I think I've probably said as much as I need to for the moment, but it's been very helpful for me thinking about what I'm trying to think about. So good. I hope we'll continue in next year and talk about these things and other things perhaps as well. Yeah.
We will definitely. Okay, well, thank you. That's for wonderful final notes, honestly. So yes, enjoy your Christmas break. I hope to see you everyone next year. Again, I will send you in the beginning of 2021, I will send you a calendar. If you want to present something else, or if you want to present something for the first time, this is supposed to be a reading group, so please just let me know. And yeah, just practical issue. Aurelian, thank you for being the technical official host. And please, when the meeting is over, you will have the meeting saved to your laptop. And if you can send it to me using Dropbox, I will then upload it to YouTube. And that's pretty much it. Thank you a lot, everyone. Enjoy your Christmas.
Thank you.
Hanukkah Sameach.
Hanukkah Sameach.